Hello friends, so hope you enjoying your studies. Again we are back with a new concept video and I would like to say all of you welcome to this Misostudy class over where we are going to start a new concept, a new topic. New concept in the sense that this is not your regular lecture or theory class. Here we are trying to get the firm grip on the concepts, fine, by means of revision, by means of attempting problems and so on. So, this is in continuation with the JEE Advanced or Mains or NEET pattern exercise practice. So, here it is for your JEE Mains exam. This chapter communication system is very important and that too it is a very simple chapter. Okay. So, because of this reason what I would like to say, now as I will start discussing one by one various problems. So, you should try to focus over here and by this means you may ensure roughly 2 to 3 questions, around 10% or less than 10% weightage. So, nearly 8 to 12 marks, fine. So, with this positive aspect, let us start this discussion of communication system JEE main pattern exercise. One thing I would like to assure from our side, that is from Misostudy side, that time to time we will definitely come up with more number of problems in this particular category. Okay. So, here it is your first question. What we tried to incorporate in these questions, we tried to incorporate almost all possible topics, subtopics of this chapter, fine. So, this question is 1000 kilohertz carrier wave movement. This term comes in front of your eyes, an idea should come in your mind what is the meaning of carrier wave. So, 1000 kilohertz carrier wave is modulated with 800 hertz audio signal. So, obviously, this 1000 kilohertz carrier wave is responsible to carry this 800 hertz audio signal. What are the frequencies of first pair of side bands? Fine. Although it is a very simple question, but I thought let us start from this question so that I can mention a very simple result also over here. So, let us start this discussion. Problem is in front of you. We just want to find the left side, right side pair, okay, side bands. That is why it is mentioned at side bands. So, the question is in front of you. It is your answer. FSB, that is frequency of side bands. Okay, this is the symbolic representation, is equal to. Now, frequency of sideband is equal to frequency of carrier wave plus minus frequency of modulated wave. Okay. Once again, this formula is very simple. Frequency is equal to frequency plus frequency. But what type? This is sideband, this is carrier wave and this is modulated wave. So, first you have to add, then you have to subtract, means plus minus both way you have to find the values over here. So, what you should have to do, just use this value of 1000 kilohertz, okay, plus minus this 800 hertz. So, 800 hertz means 0.8 kilohertz, fine, 0.8 kilohertz, simple. Now, add and subtract, ultimately you will get this 1000.8 kilohertz and 99.2 kilohertz as your answer, fine. So, from here you can say option A is correct option as it is mentioned in this particular options. So, this question is simple, but my idea was just to emphasize on this basic formula, fine. So, now let us move ahead for the discussion of another problem over here, and in this problem definitely I would like to write down only the basic formula used, fine. So, students, this is your question number 2. An optical fiber made up of glass with a core of refractive index of 1.55 and is clad with another glass with a refractive index of 1.51. You know, core and cladding refractive indexes are different. So, that is why they are mentioned during the discussion of this topic in theory classes. I explained properly. Fine. Now, launching takes place from air. What is the value of critical angle for core clad boundary? So, first I will try to draw a very simple diagram. Fine. And then I will try to show you how you can calculate it. So, let me allow to use this space for drawing the diagram. This is actually your fiber OFC cable, that is optical fiber cable, is in the form of a cylinder. That is why I am trying to show it like this. And then this portion is something which you can say is core. Fine. And outer white boundary is what? That is cladding. This is core and white boundary is your cladding. Fine. So, now this is core, means refractive index of this core is different as given in the problem, and refractive index of cladding is different. So, let me allow to write down the formula which is applicable over here, that is sin theta c, that is critical angle. It is mentioned over here. What is the value of critical angle? So, we are trying to find out this critical angle sin theta c. Sin theta c is equal to mu 2 by mu 1. Now, here you have to be very careful. You have to put that value upside so that you cannot get the sin theta c value more than 1, because you know the maximum value of sinusoidal function is only possible 1. So, by applying this simple rule, 1.51 divided by 1.55. So, put the values 1.51 upon 1.55. Fine. So, roughly after solving this, you can say theta c is equal to, not is equal to, but nearly is equal to 77 degrees. You just have to solve it, point something you will get as a answer, and accordingly sin theta c is equal to that number, then theta c is equal to sin inverse of that number. So, finally, I am writing this value. Fine. JEE mains students, means mathematics very comfortable, that is why I am not mentioning all these terms. Simply what I tried to explain you the basic idea. Okay. Now, let us move ahead for the next problem. So, students, this question again based upon the phenomena of carrier wave, modulated wave, but with reference to the modulation index. Fine. So, now just try to understand the problem first. If carrier and modulating signals are given by, this is your carrier wave, this is your modulating wave, then the modulation index is how much? Okay. So, first I think I should write down the formula. Fine. Which formula you are supposed to use, then I will explain these two relations. Fine. So, modulation index, modulation index let us use this space. Fine. Modulation index M is equal to Vm, that is modulated wave, upon Vc, that is carrier wave. Now, let us try to pick the values of modulated and carrier wave. That place for this explanation I am going to use this place, that is why I shifted this explanation. Now, as you can see, Vm is equal to this much. So, if I am writing Vm is equal to Vm basically prime, that prime term, I think I should use this prime over here, sin omega T. The formula is given to you in this manner. Fine, the equation is given. Similarly, you can compare this relation also. So now Vm means Vm prime, this is 12, and over here Vc prime is equal to 20. So what I am supposed to do, I will use it as 12 upon 20. That will give me 6 by 10 or 3 by 5. Fine. So if you solve it easily, you can get answer is equal to 60%. Fine. 5 add a point, 5 6 30, and accordingly 60%. So correct option is your C. So as you can see, just by properly looking into these equations and using this formula, very easily you can find out the solution of this particular question. Fine. One thing I am sure now at least you can realize that this topic is not a difficult one. This topic is simple, but what exactly required, and that I am trying to show with the help of these explanations, that formulae required. At least you should be comfortable. Fine. So here comes your question number 4. If the bandwidth, that is BW, in general during the discussion of theory of this chapter I explained you, if the bandwidth is 0.8 eV, fine, then the wavelength of the light emitted is how much? Now sometimes you may find these type of questions, what exactly they want to ask, why exactly this is something. Fine. If you just start looking this question from the point of view of your photoelectric effect concepts, you can easily find out, okay, they are in a process to find out the wavelength. That's good. So if they are trying to find out the wavelength, then nobody can stop me to write down this formula. Yes, obviously I can write down this formula. Now I know that this nu is equal to as nu, that is frequency is C by lambda. So what I can do, I can write down with the help of a different color chalk, E is equal to SC over lambda. Now the value of lambda you are supposed to find. Fine. C 3 into 10 to the power 8 meter per second, H 6.63 into 10 to the power minus 34, and the value of energy which is given over here. Now here you have to work out something. Why? Because it is given in 0.8 electron volt. So multiply this 0.8 by 1.6 into 10 to the power minus 19. Accordingly you can get the result. Fine. So let me allow to put these values. Let's use this space. That is lambda is equal to 6.64 into 10 to the power minus 34 given into 3 into 10 to the power 8 upon 0.8 into 1.6 into 10 to the power minus 19. Solve it. Fine. After solving, definitely I am not going to solve it, not going to multiply it. Lambda is nearly equal to 1553 into 10 to the power minus 9 meter. This is your answer. Fine. So accordingly you can change your option. That way you can say 1553, that is C is the correct option, nano. So either write it like this way or you can use the values as given in this particular options. The approach is simple, but what is difficult over here? Now try to understand. I am sure few of you may smiling, oh that is simple question. Imagine yourself in an examination hall and then you have to solve, multiply and divide these numbers. Then situation is going to be different. Fine. If you are not comfortable with basic calculations, which you should be, must be, then things are going to be slightly difficult. Fine. And these questions, they are very simple, but definitely they will consume 2-3 minutes just because of the calculation involved. Fine, because I solved this problem before coming into this lecture, that is why I know the value is 1.1553 into 10 to the power minus 9 meter, otherwise I will have to solve, so obviously it will take time. So make your calculation fast, otherwise free of cost you will not only lose 4 marks, but you will also get penalized by minus 1 marks, okay, and definitely no one will appreciate this approach. So please make yourself comfortable from the point of view of your simple calculations. In modern physics, obviously I am sure you learned lot of calculations, so utilize that concept here, fine. One more thing I would like to share with you, H into C, you know the value is fixed, multiply it and remember that value, that is 6.63 into 10 to the power minus 34 multiplied by 3 into 10 to the power what? 8. Multiply it, remember that number. That way you can save lot of time. Fine. Time to time I will keep on providing these type of tips. Next question is, a carrier is modulated simultaneously by 3 sine waves. One wave, let us say like y1 is equal to y naught sine omega 1t, another is similar and so on, of modulation indices 0.3, 0.4 and 0.5 respectively. The net modulation index is how much? Very simple question, but if you are unable to recall the formula, obviously things are going to be difficult because of this modulation index. Fine. Definitely I picked this problem to emphasize on this aspect, okay. So let us start to understand, to remember rather, nothing is to understand. In a formula either you are able to recall it or unable to recall it, fine. So let me allow to mention the formula over here, that is M, that is modulation index net, is equal to under root m1 square plus m2 square plus m3 square plus so on. Fine. Over here m1 is 0.3, 0.4, 0.5 respectively. So let us start putting these values. So m1 0.3 means 0.3 whole square plus 0.4 whole square plus 0.5 whole square. Solve it. Fine. As you solve it, you will get the answer nearly, because I solved it before coming to this video shoot, it is 0.71. Okay. So this is your correct answer, that is C is the correct answer. But what you have to remember, that is this result. Okay. Net modulation index. So you can realize one thing, at least 2 questions till now I explained you using this modulation index. Fine. All these things are going to be the part of your video shoot. So at any point of time you can recall, you can recheck them. But at least just create a small you can say A4 sheet of these simple results of this chapter, that is communication system. There are just few formulae over here, and if you just mention those results and paste the paper in front of your study table, obviously in a week or so you are going to be comfortable. Week means 7 days time, not week means you are not strong, okay. So here comes a next situation, that is a new question. Let us make the this green board more clean so that we can use it properly. Now this is question number 6. Fine. First I will explain this long problem to you. I do not want to come in between your question and you, that is why I am making a distance. The number of AM means amplitude modulated, the number of AM broadcast stations that can be accommodated in a 250 kilohertz bandwidth for the highest modulating frequency 12.50 kilohertz. Fine. If formula is not in your mind, this question will watch you and you will watch this question. Result? Nothing. Fine. Till now I am sure you must have realized that this chapter is simple, but at least you have to put some efforts to realize some basic results. Okay? So, let us try to find out the formula. I think students, if I will use this space available over here, you will not mind it. Okay? So, I do not want to move very much away from your this position, that is number of channels, equal to bandwidth B dot W, not black and white but bandwidth, okay, upon 2 into highest frequency. Fine. 2 into highest frequency. Let us try to put the values. So, it is number of channel is equal to 250 upon 2 into 12.50. Okay. So, answer is itself clear, that is 10 stations. Fine. 10, that is B is the correct option. 10 stations can be accommodated in this particular bandwidth. Fine. Why is the highest side frequency is 12.50 kilohertz, because kilohertz, so that is why I not mentioned anything, I simply solve it. Fine. And if you are comfortable in any calculation, this is very important, then in examination hall, please try to save even a single minute of your examination time. That 1 minute you can use somewhere else, and by that means, let us say that is a simple question, you may score 4 marks. Fine. So, in competitive exams, even a single mark is very important. It may decide whether you are in or out, whether you are going to get a good institution, choice of your stream or not. Fine. So, be careful fight for even single marks. Then comes this next question. In this particular question, what we are going to discuss, that I will definitely show you. This is the problem. The modulation index of an AM wave is changed from 0 to 1. Okay. Need not to read too much in between the lines. This is nothing digital electronics, simply 0 to 1. Fine. The transmitted power is how much changed? Fine. Initially, when I presented this question to many students during my teaching tenure, they normally started thinking like something digital is going on, 0, 1, some logic gate, something like that. No, not at all. Fine. What exactly? A simple formula and very basic mathematical calculation, that much is required, nothing else. Fine. So, let me allow to write down that formula. PT, power transmitted, that is why I am using PT. So, power transmitted is equal to modulation index AM wave is changed from 0 to 1. So, transmitted power. So, transmitted power is equal to PC, fine, that is carrier wave, fine, modulated wave, carrier wave, PC 1 plus m square by 2. This is the formula, fine. Now, what is this m square? M square is nothing but 1. 0 minimum, then change to 1. So, you can say it is going to be PC 1 plus 1 by 2. Okay. Now, what does this mean? It means 1 plus 1 by 2, that is 3 by 2, that is 1.5. Okay. So, PT is equal to 1.5 PC. Now, if you have proper understanding, then from here onwards no calculation required. Reason? You may say percentage increase in power is 0.5 upon initial 1 multiplied by 100. Fine. But if you are not pursuing that way, you can simply say initially the power was 1, now it is 0.5. So how much increment is? You have 100 rupees, I am giving you 50 rupees more, so 50% I am adding. So simple solution is it is going to be increased by 50%. Fine. So what exactly required? This formula only, and then you can put the values accordingly. All these problems, when I was speaking, when I was preparing, the only point in my mind was that being the student of engineering stream, some amount of simple mathematics, that much is possible as per the scope of this chapter, I must include. So that is why I am using these type of things. Fine. Otherwise in this chapter it is a very simple facts given over here. Fine. Now let us move for the another problem, that is a ground receiver station in receiving a signal at 5 megahertz transmitted from a ground transmitter at a height of 300 meter located at a distance of 100 kilometer. Okay. So first let us try to translate these first 2-3 lines. Fine. Transmitter at a height of this much located at a distance of 100 kilometer means transmitter and receiver are separated by a distance 100 kilometer. Okay. So first what I will do, I will draw the diagram. Fine. So this is one tower, it is let us say transmitter T. Fine. And then another tower, this is receiver, and the distance between transmitter and receiver is 100 kilometer. It is given in the problem itself. Fine. Let us read another line. Identify whether it is coming via ground waves, space wave, sky waves, satellite communication. Fine. So first take a look of this diagram, then I will tell you something over here. Transmitter and receiver are situated 100 kilometer away from each other. Okay. So you can say ground waves. Now come on to the options. Ground wave propagation is not applicable over here. Fine. Now that diagram is not very useful for us, it was just to give you the feeling. So ground waves are not possible. Okay. About satellite communication, you can say that yes, this can be used, but try to recall in theory classes what we discussed. There are two types of basic communication mode. One is point to point, another is point to everywhere. So satellite is basically used for universal type of thing. With the help of one satellite over entire India you can get the TV transmission. Fine. One to many, that is. So let us try to find out which one is the correct option. So this is something which we are going to discard, that is, this is a point to point. Ground wave, not possible. Now what are the possibility? Space wave, sky wave, two possibilities. Okay. Let me mention an important fact over here. What is that fact? Fact is, if you do not have the at least basic understanding or nature of ground wave, space wave, sky wave, satellite mode, then this question is going to be difficult for you. But try to recall during the actual you can say videos of theoretical classes. There we properly explained what is the meaning of ground waves, what is space wave, what are sky waves, and so on. Fine. So now on the basis of that knowledge, using some small amount of calculation, we will try to find out which option, B correct or C correct, because A, ground wave, you can discard just by watching once. Satellite communication, it is one to many, so put it aside also. Let us start for the analysis of B and C and how exactly you are going to solve this problem. Now this formula which I am going to mention now, I hope you will realize, yes, we already discussed this formula. Maximum distance covered by space wave. Fine. Maximum distance, it's a range obviously. Maximum distance covered by space wave. How much it is? It is under root twice RH, where h is the height of the tower and r is the radius of the earth. Fine. So let's put the value over here, that is 2 into 6.4 into 10 to the power 6 multiplied by 3 into 10 to the power this 300 meters. So 3 into 10 to the power 2. So when you solve it, you will get it as 62 into 10 to the power 3 meters. That you can say 62,000 meters. Fine. Okay. 62,000 meters means what? Okay. Just try to compare it with the 100 kilometer distance. 100 means 100 multiplied by this 1000. So 100 into 10 to the power 3, it is less than that. So space wave is also not applicable over here. So only possibility is now left with what? That is sky wave. Fine. So sky wave, for sky wave I think I should write down a basic formula over here also. For sky wave, fine, transmission possible. Okay. For sky wave, transmission is possible, and that way you can easily find out yes. So only correct option. I am not going further calculation which is not required. Fine. You should be very careful with the merit of the question. If in let us say 50 seconds you can solve a problem, there is no point of wasting next 40-50 seconds onto that problem. Fine. So first two options we discarded using our basic understanding. For a space wave I used a very simple formula to calculate, and then moment I realized that sky wave is the correct mode, no need to further understand this any concept over here. Fine. Otherwise also I can talk in terms of frequency and all these things, but that is not required. I can also spend some more time, but here we are not spending time. In Misostudy we love to go for the quality, not quantity. Fine. So let's move ahead with next question. A TV tower has a height of 75 meter. Okay, I love to create a TV tower. Fine. That is 75 meters. Fine. What is the maximum area up to which this TV communication can be possible? Nowadays actually this is discarded almost, because now you have a digital set-top box at your home, a very small parabolic shape antenna that is known as a dish antenna, and satellite communication. It was something that was used in like 10-15 years back. So, but the question is there, so let us try to find out the correct solution of this problem. So, this is the situation, and what will happen? This TV tower will transmit like this. Fine. So, these waves will come. So, actually what will happen? You just want to find the area. Area means because due to the curvature of the earth basically, it is not possible to transmit for the very long distance. Fine. So, let us try to find this particular question, what exactly the problem is. Fine. And that is why I created this. Now, area to be covered. Area to be covered is given by, area to be covered is given by pi into 2RH. Basically it is pi r square. So simply by using r square means 2 into RH under root, just 2 minutes back I used. So directly I am putting the values pi r square, area of a circular shape, fine. So pi r square is 2 under root 2 RH. So directly I am putting the values. You can say 22 upon 7 into 2 into 6.4 into 10 to the power how much, 6 into height is how much, 75, fine, 75, 6.4, 75 meter. And then if you solve it, you can easily say that this 3018 is the correct answer, fine. So as such nothing is difficult over here, simply you have to use a very simple basic result, and just by one step calculation you can get the values. Now students, here comes your next set of problem. Now please listen very carefully. The number of AM broadcast stations that can be accommodated in a 300 kilohertz and width for the highest modulating frequency is 15 kilohertz will be how much? Stop the video. Take your time, solve it. Reason being, the same problem I explained. You may say, sir, why you are repeating the problem? I want to check in last 9 questions what you learned. Because at least if you are focused, moment you will see this question, you will stop yourself, you will write the solution and then you will match it, fine. So just because to take a small type of test or something, very clever approach I am doing this, maybe any problem, I mean the concept is repeated, it is not like that, same problem is repeated, some different wordings, but the concept is same. What the formula I mentioned? Again I would like to mention number of channels. Again I am repeating this formula just for your understanding. Number of channels, bandwidth upon 2 into highest frequency, fine. 300 kilohertz divided by 15 kilohertz into how much, that is 2. So 30, 300 by 30, that will give you 10 stations. Okay. So actually this entire chapter communication system is there so that you can score good marks, only for that reason. So I would like to say we should stop over here. Till then keep revising of this the concepts of this chapter. Very soon we will be back with new videos. Till then take care of yourself. Have a nice time.